24, it's an implicit differentiation question here. I've got x and y's all over the place. I've got to find dy by dx in terms of x and y, and it tells us that this point of minimum. I'm going to find out what p is and what k is. So here we go. So differentiating then in terms of x. Well, first I'm going to use the product rule. I've got y squared times x. So it's y squared times x differentiated, which is just y squared times 1. And then I need to differentiate the y squared and multiply by x. Differentiate the y squared in terms of x is 2y, because that's what I'd get when I differentiate y squared in terms of y. Then I need to multiply by dy by dx. And then I need to multiply the whole thing by x then. So y squared differentiated, multiply by x. The 3y's all right, that's just 3 times dy by dx. And the 4x squared is just 8. K, of course, is a constant, so it becomes 0. And then I want to dy by dx in terms of x. So the two dy by dx terms, I'll take the dy by dx out as a factor and shove the y squared on the other side, and then divide by that bracket then to get dy by dx in terms of x and y. It says point P, P is a constant, lies on C. I'm going to find out what P is, and that point is a minimum point. So I know that when x is equal to P, y is equal to 2, dy by dx is equal to 0, so I can sub those in. I'm not really bothered about the bottom line, the denominator, because I just want the numerator, the top line, to be 0 in a fraction. So the 8p must be equal to 2 squared. So 8p is 4, so p is equal to a half. Then to find out what the k is, I need to sub it back in the original equation of the curve. And I know what the x and y is at p, so I can sub the x and the half in for the x and 2 in for the y. So 2 squared times a half. 3 lots of the y, so 3 lots of 2, and 4 lots of a half squared plus k. So the left hand side is 2 plus 6. The right hand side is just 1 plus k, and the k is equal to 7. Subscribe the solution.